Okay, children, today we will discuss 12.5 activity. 12.5 activity in electricity, children. Page number 211 it is there, children. What is the aim? Please write down aim, children. What is the aim of the activity? Aim of the activity is to find the relationship between, write down, children, to find relationship between, please write down, children, to find relationship between V1, V2, V3. This is, in fact, I can write V total. I can write if you want. Please write down, children. What is the relationship? To find the relationship between total potential V1, V2, V3. I told you in the beginning, from the beginning I'm telling, battery potential is shared by three of them. Okay, so children, if ever you remember, we did series connection like this, R1, R2, R3. Please note down, children. Okay, so this is V, children. It delivers a current I. Battery potential is shared as V1, V2, V3. This total potential is equal to V1 plus V2 plus V3 that we have to show, children. Okay, how will you show? How will you show, children? What we have to do is, anyway, how we will show? How will you show this, children? You have to take three resistors, children. Three resistors you have to take across X and P. We have to keep, children. Okay, now let me take. Please see here, children. Any potentials you can take, children, your wish, any potential, 2 ohm, let me say 4 ohm, let me say 6 ohm, children, anything you can take, children. You take 3 resistors and 2, 4, 6, children. Okay, let me say 24 volts battery I'm selling. Here you keep 1 voltmeter, children. Here you keep 1 voltmeter. Voltmeter is always connected in
Parallel.
parallel. Voltmeter is always connected in parallel. 3 voltmeters you are connecting, children. 3 voltmeters you are connecting across each one of them. Okay, children. Now, what you do? First, let me find total resistance. Can anyone total resistance? They are in series.
12, sir.
12 ohms. What is total potential, children? 24 volts.
24 volts.
What is current? Total current I is equal to V by R. 24 by 12, that is 2 amperes. So, what is current across I2, I4, I6? Anyone?
2 amperes, sir.
2
Everywhere it
amperes.
is 2 amperes. Why everywhere it is 2 amperes? Current is?
Constant.
Current is constant in series connection. In series connection, current is constant. Now, this is actual activity. V2, V4, V6. V2 is IR2. V4 is IR4. V6 is IR6. What is the current, children? Current everywhere. What is the current? Same current.
2
Okay.
amperes.
2 amperes is flowing. 2 into 2. 2 into 4. Please copy down in the textbooks, children. 2 into 6. 4 volt, 8 volt, 12 volt. 4 plus 8 plus 12 is how much, children? 24 volt,
24.
which is nothing but your total potential. So, children, total potential is equal to V1 plus V2 plus V3 always. So, battery potential is shared by three of them. Battery potential is shared by three of them. If three are equal, they will share equally. If three are different, according to their resistors, they will share. Battery potential will be shared as V2, V4, and V6 across each one. This is becoming 4 volt. This is becoming 8 volt. This is becoming 12 volt. This is becoming 12 volt. Okay, children, like this we have to find. Just for a sample, I am showing, children. Just for a sample, power using one formula. Any one formula will find out. Which formula you want? You tell me, children. Which formula you want?
PI.
Okay, power. He is saying we want P is equal to VI. Okay, children. So formula P2 is equal to V2I. P4 is equal to V4I.
V8I.
Why I2, I4, I8 I am not writing? Because
Eight Because current is constant.
across 2, what is the potential? Anyone?
4 volts.
4 into 2.
2.
Across 4, how
8
much is the
into 2,
volt?
sir. 8 into
8
2.
8
volts.
8 into 4. Across 6 ohms, how much?
Sir, 8 into 2, sir.
8 into 12.
Okay, this is 6 no, children. V6. V6I. Across 6 ohms, how much is the potential?
12 volts.
12 into 2. Now, what is the power here?
8,
8
8
watts.
watts. 16 watts.
24 watts.
24 watts. Okay, children. So, like this, we have to find out power also. But here, our main intention is to say that total potential is equal to sum of individual potentials. Total potential is equal to sum of individual potentials. Potential of the battery is shared by three of them. Potential of the battery is shared by three of them only in series. In parallel, potential is constant. That is different issue. Here, in series always, current is constant, whereas potential is shared. Current is constant, whereas potential is shared. You should be perfect with series connection, children. Then any numerical, any sum, however they give, you will be in a position to do. Okay, children, this is next activity, children. Okay. Anyone have any doubts?